So the topic was about capacitors and capacitance, right? Okay, हम लोग का capacitors and capacitance. So in this case, जो first point हम लोग का, ठीक है? First point की पोटेंशियल, first point we discussed that capacitor is an arrangement of conductors. Just revise it. A capacitor is an arrangement of conductors separated by an insulating medium which is used to store charge or electrical energy. Right? So this we discussed last day कि capacitor क्या है? Arrangement of conductors है, which is separated by an insulating medium, right? The two conductors or whatever number of conductors are there, they are separated by some insulating medium between them. And purpose क्या है इसका? To store charge or to store electrical energy, right? So now the question is कि why a single conductor cannot be used to store charge? तो बहुत simple सा बात है देखो. Suppose if you have an isolated conductor, let us talk about first term capacitor of an or capacitance of an isolated conductor. Then it will be clear कि ऐसा possible क्यों नहीं है. बेसिकली क्या होता है? सपोज हमने कंसिडर किया कि वी हैव अ स्फेरिकल कंडक्टर. मान लो मेरे पास एक स्फेरिकल कंडक्टर है ऑफ रेडियस r एंड वी हैव चार्ज्ड इट. यू नो कि इलेक्ट्रोस्टैटिक कंडीशन में चार्जेस कहां पे रहता है? वेयर डू द चार्जेस स्टे? ओनली ऑन द सरफेस. ठीक है, ये बेसिक कंडीशन है. कभी भी अगर तुम्हारे पास कोई भी कंडक्टर है, उसको जब चार्ज करेंगे तो इन इलेक्ट्रोस्टैटिक कंडीशन अंदर में फील्ड और अंदर में एक्सेस चार्ज दोनों क्या होगा? जीरो होगा. द चार्ज विल लाई ओनली ऑन द सरफेस एंड इलेक्ट्रिक फील्ड विल बी परपेंडिकुलर टू द सरफेस. इलेक्ट्रिक फील्ड पता है? ठीक है, एनी चार्ज प्रोड्यूसेस इलेक्ट्रिक फील्ड दैट विल बी परपेंडिकुलर टू द सरफेस. So suppose if the charge is q, so we know that potential of the conductor, that is the potential of the surface of the conductor. इसका formula क्या होता है? For a spherical conductor we know formula is charge q divided by 4 pi epsilon naught times the radius r. क्लियर हुआ? इसका मतलब जितना मैं चार्ज दूंगा proportionally the potential will rise, right? Or you can say potential difference of the conductor with respect to infinity will become more and more. अब जब potential rise करेगा, when the potential will keep on increasing, then the electric field around it will also keep on increasing itself. और अगर इलेक्ट्रिक फील्ड बहुत स्ट्रांग हो गया तो क्या करेगा? सराउंडिंग मीडियम को क्या कर देगा? आयनाइज कर देगा. दैट इज कॉल्ड डाइलेक्ट्रिक ब्रेकडाउन. इसीलिए सिंगल कंडक्टर पे हम लोग बहुत ज्यादा चार्ज को कभी भी नहीं करते. Is that one clear? That is why a single conductor cannot be used to store large amount of charge. Okay? Now, if you take the ratio of Q by V, that will be constant. यहाँ पे इस constant का वैल्यू कितना है? It is 4 pi epsilon naught times the radius. Right? By definition, this constant is equal to C, which is known as capacitance of the conductor. Which is known as capacitance of the conductor. So by definition, what is capacitance of a conductor? We can say it is the ratio of charge stored on it to the potential of the conductor. Right? यहाँ हम बोल सकते हैं it is numerically equal to the amount of charge which is to be supplied to increase the potential by unit amount. Right? Charge per unit V. If charge increases, V also increases. ठीक है? Now the problem is capacitance of a spherical conductor कितना है? 4 pi epsilon naught r. Yes or no? And we already know कि 4 pi epsilon का वैल्यू कितना था? 1 by 9 into 10 to the power 9. यूनिट क्या था इसका? याद करो. The unit was Newton meter square per coulomb square. ये यूनिट था. ठीक है? That means if we have if we have a conductor of capacitance 1 farad, right? Capital F represents what? The unit called farad, which is the SI unit of capacitance. SI unit of capacitance क्या है? Farad. समझ में आया? So if we have a conductor of capacitance 1 farad, अगर मुझे 1 farad capacitance चाहिए, then R कितना होना पड़ेगा? बोलो. Then the value of R needed will be कितना? If I want to make this thing as 1, so the value of R should be 9 into 10 to the power 9 meter, which is even much larger than the radius of Earth. यानी अगर मेरा पूरा अर्थ भी एक कंडक्टर होता, उसका भी कैपेसिटेंस 1 फैराड नहीं हो सकता. ठीक है. दैट इज व्हाई फैराड इज अ बिग यूनिट ऑफ कैपेसिटेंस एंड प्रैक्टिकली हम लोग फैराड को यूज नहीं करते. प्रैक्टिकली हम लोग कौन सा यूनिट यूज करते हैं? माइक्रो फैराड, मिली फैराड, नैनो फैराड. इज दैट क्लियर? समझ में आया? तो ये क्वेश्चन में पूछ सकता है कि व्हाई 1 फैराड, though it is a SI unit, why is it not used to measure capacitance practically? Reason is what? Reason is that to have capacitance of 1 farad, the dimensions of the conductor needed is much, much large. Right? It is a very large unit of capacitance. So 1 farad is a very large unit of capacitance because we saw if we have a spherical conductor of 1 farad capacitance, its radius should be around 9 into 10 to the power 9 meter, which is huge. That is why practically we always use the sub-multiples like micro, nano, picofarad. What is it? हो गया? प्रियांश विश्ववर्षिश, हेलो. यस सर, वो डबल हो सर. डन. So unit has farad. The full name is FARAD. It is defined from the name of Faraday, right? And symbol is capital F. Faraday मत लिखना. Faraday is the unit of charge. Faraday अलग होता है, Farad अलग होता है. Farad is unit of capacitance. Faraday is unit of charge. ठीक है? Done? ये फॉर्मूला किसके लिए था? 4 pi epsilon r is the capacitance of what? Isolated spherical conductor. ठीक है? हो गया यहाँ तक? Next, what we discussed that instead of a single conductor, तो अब देखो सिंगल कंडक्टर सफिशिएंट क्यों नहीं है? क्योंकि सिंगल कंडक्टर में अगर हम लोग चार्ज स्टोर करेंगे तो क्या जो पोटेंशियल है वो राइज करेगा, और जितना पोटेंशियल राइज करेगा अराउंड द कंडक्टर बी स्ट्रॉन्ग, दैट कैन कॉज डाई इलेक्ट्रिक ब्रेकडाउन ऑफ द सराउंडिंग. तो चार्ज क्या करने लगेगा? लीक करने लगेगा. तो ऐसा हम लोग क्या कर सकते हैं सो दैट वी कैन स्टोर मोर चार्ज without causing any dielectric breakdown of the surrounding medium. For that, we use the arrangement known as capacitor. So remember, capacitance is the property of conductor, but capacitor क्या है? एक suitable arrangement of conductors है, which is used to store charge. समझ में आया? हर कंडक्टर का कुछ ना कुछ कैपेसिटेंस होता है, but the system of conductors which is used to store charge is known as a capacitor. तो कैपेसिटर में जनरली हमारे पास क्या होता है, हमारे पास टू कंडक्टर्स होते हैं ऑफ एनी शेप. डिपेंडिंग ऑन द शेप द वैल्यूज ऑफ कैपेसिटेंस विल बी डिफरेंट, and one of them is charged positively, suppose plus q, right, and the other one is charged negatively and the charge on it will be minus. अब देखो एडवांटेज क्या है, अगर मैंने एक को चार्ज प्लस क्यू किया, दूसरे को ग्राउंड कर दिया, सो दैट माइनस क्यू डेवलप्स ऑन द नियरर फेस, तो इस कंडक्टर का पोटेंशियल क्या हो जाएगा, इट विल बी पॉजिटिव बिकॉज ऑफ इट्स ओन चार्ज, बट एट द सेम टाइम नेगेटिव बिकॉज ऑफ द नेबरिंग चार्ज. तो जितना मेरा क्यू बढ़ेगा, क्या पोटेंशियल उसके अकॉर्डिंग उतना ज्यादा राइज करेगा, नहीं करेगा. क्यों नहीं करेगा, because here the potential of the positive conductor is not with respect to infinity, with respect to the negative plate, negative conductor. तो जितना प्लस क्यू बढ़ेगा उतना माइनस क्यू भी बढ़ेगा. तो अल्टीमेटली व्हाट विल हैपन, अगर अकेला प्लस क्यू रहता तो पोटेंशियल जितना राइज करता अब उतना राइज नहीं करेगा, बिकॉज द नेबरिंग माइनस क्यू इज ट्राइंग टू लोअर द पोटेंशियल. So this is the advantage why a system of conductors is better to store charge, right? तो यहाँ पे क्या होगा, यहाँ पे याद रखना कि Q is termed as charge stored on the capacitor. Q is known as charge stored in the capacitor. Actually total charge in capacitor कितना होता है, बोलो. What is the total charge of a capacitor? Zero. Q minus Q zero. But जब हम पूछते हैं कि what is the charge stored in capacitor, it means magnitude of charge on each conductor. Okay, and if you find out, suppose this one is named as 1, this one is named as 2, then V, which is potential difference of 1 minus 2, is known as potential of the capacitor. This is known as potential of the capacitor. So again remember, potential of the capacitor actually potential नहीं है, क्या है, potential difference between the conductors. ठीक है. So again what is found, again it is found that Q and V are directly proportional, right? Or we can say Q divided by V will be constant, and this constant C is termed as what? Capacitance of the capacitor. Capacitance of the capacitor. समझ में आ रहा है, right? तो कैपेसिटेंस ऑफ द कैपेसिटर मतलब क्या है, रेशियो ऑफ चार्ज स्टोर्ड, राइट, टू द पोटेंशियल डिफरेंस बिटवीन द कंडक्टर्स. Now, one form of capacitor that we discussed last, that is called what? Parallel plate capacitor. Yeah? The common form of capacitor that is used in most of the circuits, that is known as what? Parallel plate capacitor. So parallel plate capacitor में क्या होता है, in this we have two identical, generally identical होगा, compulsion नहीं है, but generally identical. So we have two identical thin plates, ठीक है. We have two identical thin plates. Suppose ये एक plate है, thin metallic plate. Now I am drawing the plate of square shape. Important नहीं कि square ही हो, it can be circular also. ठीक है, तो we have a thin conducting plate, and parallel to it we have another thin conducting plate of the same area. दोनों का surface area क्या है, equal है, right? Now suppose area of each plate is A. Area of each plate is A, and distance between the plates is D. तो जनरली क्या होता है यहाँ पे कि D is much small as compared to A. D क्या होगा, as compared to A बहुत छोटा होगा. It is designed in such a way. Now one of the conductors is given a positive charge and the other one is earth grounded, or automatically develops a equal amount of negative charge, right? अब कंडक्टर्स को मैंने प्रॉपर्टी बताया था, याद करो क्या प्रॉपर्टी था, कि जब भी हम दो पैरेलल कंडक्टर्स को एक साथ रखेंगे, कंडक्टिंग प्लेट्स को एक साथ रखेंगे, तो आउटर सरफेसेस पे, आउटर सरफेस मतलब टू द लेफ्ट ऑफ द फर्स्ट प्लेट और टू द राइट ऑफ द सेकंड प्लेट, यहाँ पे चार्ज क्या होगा, टोटल चार्ज बाई 2. अब अगर मैंने पहले वाले को चार्ज दिया प्लस क्यू एंड सेकंड वाले को चार्ज दिया माइनस क्यू, तो टोटल चार्ज कितना हो गया, 0 हो गया. So automatically what will happen, on the outer surface of the first plate here the charge will be 0, and the entire plus q charge will come on the inner surface. Will come on the inner surface, right? And the opposite surface will develop a charge minus q. ठीक है, क्योंकि अब ये दोनों जो चार्ज कहां पे आ रहा है, ओनली ऑन द एडजेसेंट सरफेसेस. So these two will behave like what? Sheet of charge. Gauss law में पढ़ा था ना, sheet of charge. Yes or no? So these two plates, these two surfaces will behave like sheet of charge, and they will produce a uniform electric field between them. Okay, if you connect, this will happen when we connect the capacitor to some source like battery or cell, right? So now what is found here, if the plates are given charges minus q, then the charges appear on their inner surfaces, right? And a uniform electric field is developed in the space between the plates. Is that clear? तो ये जो यूनिफॉर्म इलेक्ट्रिक फील्ड होगा, ये कितना होगा? What is the amount of uniform electric field? Now imagine, see, this surface, the positively charged surface is like a sheet of charge. Yes, yes or no? The positively charged surface is like a sheet of charge. अच्छा, इस शीट के अंदर टोटल चार्ज कितना है? प्लस क्यू. इस शीट का एरिया कितना है? ए. तो इसका चार्ज डेंसिटी कितना हो जाएगा? सिग्मा कितना हो जाएगा? 2 डिवाइडेड बाई ए. एंड जो अगला वाला सरफेस था, दिस इज अनदर शीट हैविंग चार्ज कितना? माइनस क्यू. एरिया कितना है? ए. तो व्हाट विल बी द चार्ज डेंसिटी? माइनस क्यू बाई ए. दिस विल बी द सिग्मा ऑफ दैट शीट. So there are two sheets, they have equal charge densities, but one is positive, the other one is negative. जब ऐसा होता है तो इलेक्ट्रिक फील्ड बिटवीन द प्लेट्स कितना होता है? याद करो, एप्लीकेशन ऑफ गॉस लाइट विल बी सिग्मा बाय, ये एप्लीकेशन ऑफ गॉस लॉ में था, सिग्मा बाय एप्सिलॉन नॉट. तो सिग्मा कितना होगा? Q बाय A. Therefore, potential difference between the plates, potential difference between the plates, V कितना हो जाएगा? It will be E multiplied by D, because we know potential difference is given by what? Minus integration of E dot dl from negative to positive. But ये E तो uniform है. The E is uniform, so it will go out of the integration and simply we'll have E into distance between them. पोटेंशियल डिफरेंस पर यूनिट डिस्टेंस होता है इलेक्ट्रिक फील्ड. तो पोटेंशियल डिफरेंस कितना होगा? इलेक्ट्रिक फील्ड मल्टीप्लाइड बाय द डिस्टेंस, राइट? समझना है? पोटेंशियल डिफरेंस बाय डिस्टेंस इज इलेक्ट्रिक फील्ड. So electric field into distance will be potential difference. So that we can write V equals to QD by A epsilon naught. Therefore, as per definition, capacitance जो कि होता है Q by V कितना हो जाएगा? Epsilon naught A divided by. ये जो फॉर्मूला है, this is the formula for capacitance of a parallel plate capacitor. This is the simple formula for finding capacitance of a parallel plate capacitor. Right? तो किसी भी अगर तुमको कोई भी क्वेश्चन में बोला कैलकुलेट द कैपेसिटेंस ऑफ दिस कैपेसिटर, तो सिंपल टेक्निक क्या है? Just find out the potential difference between the positive and the negatively charged conductor. That will be proportional to the charge Q. Ratio of that will be the capacitance. Okay? यहाँ तक क्लियर? तो बेस्ड ऑन दैट मैंने लास्ट से बोला था कि टू सॉल्व वन क्वेश्चन, राइट? लास्ट से बोला सॉल्व वन क्वेश्चन. व्हाट वाज द क्वेश्चन? এই অবধি আগের দিন করিয়েছিলাম, ক্লিয়ার আছে? तो देखो यहाँ पे जो क्वेश्चन है एक्सरसाइज में, व्हाट इज द क्वेश्चन, लेट्स राइट इट डाउन एंड ट्राई टू सॉल्व इट. कैसे इसको सॉल्व करेंगे हम लोग, देखो लिखना हो गया यहाँ तक? So the question that we have, question is in a parallel plate capacitor, in a parallel plate capacitor with air between the plates, in a parallel plate capacitor with air between the plates, each plate has an area of 6 multiplied by 10 to the power minus 3 meter square, and the distance between the plates and the distance between the plates is 3 millimeters. ठीक है? Calculate the capacitance. Calculate the capacitance. Next part है, if the capacitor is connected to a 100-volt supply, what is the charge on each plate of the capacitor? It is the charge on each plate of the capacitor. तो देखो, let us try to understand step by step क्या क्या दिया हुआ है क्वेश्चन में. कभी भी पहले बताया मैंने, कभी भी न्यूमेरिकल प्रॉब्लम होगा तो फर्स्ट राइट डाउन व्हाट आर द गिवन डेटा एंड व्हाट इज टू बी फाउंड. इट विल बी इजी टू फॉलो. So what is given here? See, first part which is given here, ठीक है? फर्स्ट पार्ट विच इज गिवन हियर, क्या क्या दिया हुआ है? इट इज अ पैरेलल प्लेट कैपेसिटर, राइट? एंड व्हाट इज द मीडियम बिटवीन द प्लेट्स? एयर. ठीक है? तो हमने जो फॉर्मूला लिखा था एप्सिलॉन नॉट, उसमें था एप्सिलॉन नॉट इज व्हाट? इलेक्ट्रिकल परमिटिविटी ऑफ वैक्यूम और एयर. एयर का और वैक्यूम का लगभग सेम होता है. तो एज द मीडियम बिटवीन द प्लेट्स इज एयर, वी कैन यूज द फॉर्मूला. की फॉर्मूला छिलो C इक्वल टू एप्सिलॉन नॉट A divided by D. This was the formula. अच्छा, now we know the value of epsilon naught is कितना? 8.85 into 10 to the power minus 12. What is the area of each plate? 6 into power minus 3 divided by D. What is the distance? 3 millimeter. But remember, in electrostatics, we are using only SI system. So you have to convert into meter. ठीक है? जो भी फॉर्मूला है, these are valid for SI only. So 3 into 10 to the power minus 3 meter. तो आंसर किसमें आएगा? Answer will come in farad, right? SI unit of capacitance is farad. So now simplify this. तो कितना हो जाएगा? ये हो जाएगा 2. So this will become कितना? 17.5. Not 5. कितना? 7 ना? 17.7 into 10 to the power कितना हो गया? देखो, -12 और -3 हो गया -15. And if this हाँ, 10 to the power -3 -3 cancel out. or you can say minus 12 minus 6 minus 15. Minus 15 at plus 3. Anyway, this will become minus 12. Or we can say this will be 17.7 picofarad. 10 to the power minus 12 की बोली pico बोली, right? Clear हुआ? First part. Second part में क्या पूछा है? If this capacitor is connected to a 100 volts pipe, what is the charge on each plate? तो हम लोगों ने स्टार्टिंग में क्या पढ़ा कि हमने बोला Q is equal to C into V. तो Q कितना होगा? So directly we can say that the charge stored will be C into V. So C we got 17.7 into 10 to the power minus 12. V is 100. Answer किसमें आएगा? Coulomb में आएगा because charge is measured in coulomb. So that will be equal to 17.7 into 10 to the power minus 10 coulomb, right? Or we can say 1.77 nano coulomb. Nano मतलब क्या होता है? 10 to the power minus 9. So this is how we can solve the question. Yeah, this is clear. About hello. Understood. अब देखो, we just discussed कि capacitor जो है, capacitor is a system of conductors and in between the conductors we have some insulating medium. Now, if the medium is varied, যদি আমি medium টা change করে দিই, if we change the medium, what will happen? Will it affect the capacitance or not? Okay, so let us try to find it out. So what is the topic, right? Effect of insertion of conducting slab between plates of the parallel plate capacitor. We have to find out कि अगर मैंने space between the plates of the capacitor में conducting slab रख दिया, slab मतलब slab means what? A thin rectangular, a thin cuboidal object, ठीक है? इसका thickness बहुत छोटा है और area, surface area काफी बड़ा है comparatively. Yes or no? Area of each face काफी बड़ा है. So we are taking such kind of a situation. So suppose initially we assume that we have a parallel plate capacitor. Now we will not draw the plates. We will draw it symbolically. Just a line. A line पर मानेगी. What is the line of meaning of the line? Suppose अगर ये एक plate है, imagine ये black surface अगर एक plate है, अगर मैंने इसको ऐसे रखा, normal to your eye level, तो क्या दिखेगा? एक line दिखेगा ना? Just the length or the breadth in one. So that line we are drawing, right? So we are drawing the normal view of the capacitor. So suppose this is first plate, right? And the other plate is parallel to it. This is the second plate. Okay. Now let's assume that both these plates have equal area. Each plate has an area, how much? A. And the first plate is connected to some source of positive charge. The second plate is connected to negative. Means पहला plate होगा positively charged, second plate होगा negatively charged. ठीक है sir? And in between the plates, we are inserting one conducting slab. Suppose the slab is like this, conductor. So this is one conducting slab which has the same area. मतलब इस conducting slab का जो area है ना, surface area, that is same as that of the plates. Area of each face of the slab is also A. This is also A, right? But the thickness of the slab is supposed T. Right? Distance between the two plates, how much? It was supposed D. So what is D here? Distance between the plates of the capacitor. What is T? Thickness of the slab. Clear? अब देखो, what we know that whenever we have any conductor placed in an external field, here it will develop induced charges, but only on the surface. Inside the conductor, field और charge दोनों क्या होगा? Zero होगा. So actually, there was some electric field developed because of the two plates, positive and negative plates. But this electric field will act in such a way so that the nearer face will develop a negative charge, the farther face will develop a positive charge, right? But inside the conductor, the field will remain zero. कंडक्टर के अंदर कभी भी इलेक्ट्रोस्टैटिक फील्ड नहीं होता है. Inside a conductor, electrostatic field is always zero. Clear? So now I want to find out. See, capacitance निकालने का simple theory क्या था? Find out the potential difference between the plates of the capacitor, right? And divide the charge stored by that, you get the capacitance. So we have to find out the potential difference between the two plates. Okay. So let us call the first plate as say number 1 and the second plate as number 2. Right? And let us call the two surfaces of the conducting plate, one as suppose क्या नाम दे इसका? नाम देते हैं मान लो C तो capacitance हो गया, कुछ और नाम देते हैं. Suppose this is called X and this point is called Y. Okay, the two surfaces we are calling as X and Y. So we can say that now potential difference between the plates of the capacitor कितना हो जाएगा? It will be V will be as per definition minus integration of E dot dl from 2 to 1. This was the definition. Okay. So we can break it down as what? Minus integration of E dot dl from surface number 2 to surface Y, and then minus E dot dl from surface Y to surface X. dl means basically the potential difference मतलब होता है work done to move a unit charge from one point to another, unit positive charge. How do we write out work done? Force multiplied by displacement. Force dot dl or dr, that is the displacement used. And since we are moving a unit charge, force by unit charge क्या होता है? Electric field ही होता है. That is why it is E dot d. Understood? 2 to 1 কারণ 2 টা নেগেটিভলি চার্জ, 1 টা পজিটিভলি চার্জ, এই জন্য পোটেনশিয়াল কার বেশি হবে? 1 এর বেশি হবে তো, ঠিক है? Potential difference between 2 and 1 मतलब क्या? If I say you V1 minus V2 means 1 is at higher potential, 2 is at lower potential. That is why we are bringing it from 2 to 1 against the field. ठीक है? बुझा गया? लास्ट क्या करेंगे? माइनस इंटीग्रेशन E dot dl from X to the surface number 1. Right? यहाँ तक क्लियर हुआ बात? We have just divided the whole path into intervals because entirely over the whole path field was not same. In the open space field is different and inside the conductor field is 0. That is why. अब देखो, in between the plates, पहले जब ये कंडक्टर नहीं था तब फील्ड कितना था? सिग्मा बाय एप्सिलॉन नॉट. तो अभी भी वो ओपन स्पेस में सिग्मा बाय एप्सिलॉन नॉट ही रहेगा क्योंकि इनसाइड द कंडक्टर फील्ड कितना होता है? 0 होता है. एंड सरफेस ऑफ द कंडक्टर विल इंड्यूस जस्ट इक्वल एंड ऑपोजिट चार्ज. ठीक है? So as we go from 2 to Y, the field will be sigma by epsilon naught, which is constant. And how much is the distance to be traveled? So let's assume say कि A से लेके Y तक this distance is suppose something like Z. ठीक है? So the electric field is sigma by epsilon naught and the distance to be traveled is how much? Z. Minus sign कहाँ आ गया? So we are automatically going against the field. So minus minus क्या हो जाएगा? Plus हो जाएगा. समझ में आया? We are going against the field ना, पहले E dot dl नेगेटिव आएगा, माइनस माइनस प्लस होएगा. ठीक है? अच्छा. Next, as we go inside the slab, Y से लेके X तक, तो Y থেকে X तक तो इलेक्ट्रिक फील्ड कत আছে? 0 আছে. Between Y and X इलेक्ट्रिक फील्ड is 0. तो इलेक्ट्रिक फील्ड ही अगर 0 है तो मल्टीप्लाई करने पे क्या आएगा? 0 ही आएगा. Next, As we go from x to 1, again the electric field is how much? Sigma by epsilon naught. And how much is the distance? Let us call this distance as suppose z dash. Okay. Plus होगा कि minus? Plus होगा because we are going against the field. So ultimately what do we get? We get sigma by epsilon naught multiplied by z plus z dash. Diagram को ध्यान से देखो. See the diagram carefully. See the diagram carefully. Can I write this? See, z dash plus t plus z will be equal to d. लिख सकते हैं कि नहीं? Z dash कहाँ पे ये plus thickness of the slab plus z will be equal to d. Yes or no? होगा? Z dash के साथ t को ऐड करो, z को ऐड करो, क्या आ रहा है? d आ रहा है ना? Distance in the place आ रहा है. So that means in place of z dash plus z, we can write d minus t, right? लिख सकते हैं क्योंकि d हमें पता है, t हमें पता है, z तो हमने assume किया था, right? So ultimately we can say कि sigma is nothing but q by a and z plus z dash क्या आ गया? d minus t आ गया. So we can see that v will be equal to q by a epsilon naught into d minus t. Therefore we can say capacitance मतलब क्या होता है? q divided by v. कितना हो जाएगा? Epsilon naught a divided by d. ठीक है? So when we insert the conducting plate, this is how the formula will be modified. Understood? तो बोलो तो कैपेसिटेंस इंक्रीज हुआ कि डिक्रीज हुआ? जब बीच में एयर था और अब जब बीच में ये कंडक्टिंग प्लेट आया और थिकनेस टी, हैज द कैपेसिटेंस इंक्रीज और डिक्रीज? Increase because the denominator is less now, na? Initially, देखो, in the absence of the plate, the capacitor was how much? The capacitance was, in the absence of the plate, the capacitance was, let's call it C0, which was epsilon naught A by D only. अब denominator decrease हो गया है, तो denominator decrease हुआ, numerator same रहा, तो क्या होगा? Fraction will increase, right? Therefore, we can say that C is more than C0. Thus, on inserting the capacitance will increase. That means for the same potential difference, now we can store more charge. Now we can store more charge in the capacitor. Yes or no? Yes, sir. Okay. Yes, sir. Everything clear? Yes, Mr. Rajesh. In the rejoin, okay, Priyansh.